You have the activate Windows on your Chalmers computer there.
Yeah, I think it's the right.
To chat with our IT support. They need to pay licenses.
Hello everyone, I'm Sushant Kumar Pandey. I'm working as a postdoc researcher at University of Gothenburg, Chalmers. So here I'm going to discuss about understanding of design patterns in software systems. So basically, my presentation will be like, first I will discuss about the motivation, that's why we are doing this. I will briefly discuss about the objective of our project that I'm working with. I will say three current work that I'm working on with higher level. I will show the results also and conclusion. I will show the results along with the work and conclusion along with the work. So this is the way that I will follow during the presentation. We all know, I will briefly go to the motivation. So we all know that nowadays everyone is using softwares and softwares are getting very extensive. For instance, WhatsApp contains around 1 million lines of code. Now modern cars around 15 million lines of code. So making those softwares is like very expensive, time consuming. So what we are trying to do, we are trying to minimize this cost in terms of money, time. So this is our objective. How we can do this? We are thinking to detect or recognize design patterns in the software systems. So design patterns are actually reusable solutions for, it is like a template for any softwares. For instance, if somebody wants to design a software, want to make a software, a similar kind of software is already exists. Just follow the template, just follow the architecture patterns of the software. It will be easy for you to make that kind of software. So this is how you can reduce the cost of your development of a software. So everybody knows that implementing design patterns is the best practice amongst engineers and developers. So this is the small motivation and some motivation about the deep learning and natural language processing. We all know that natural language processing is growing very widely nowadays, and we are also exploring natural language processing based these deep learning methods, which is like programming language models. Now, for our initial investigation, we have investigated several programming language models, and for our initial study, as this figure illustrates that this figure is like TSNE visualization of one of the programming language model from Facebook. You can see that the vector representation in it is like some 0.2 minus 0.3, and the vector representation of char is almost same like in it. So it indicates that in these vector representation of these two entities are very similar. So it means that they are very close to each other in n-dimensional space. So this is like n-dimensional space. Here we can see that the print and script tree is very close to each other. The const and struct are very close to each other because their semantic meanings are really close. So that is why they are very close. So we are also following this strategy in our initial study. So the problem that we are facing after exploring our literature, that there is no baseline for that implemented design patterns. For instance, if we want to train a model, we only collected 20 examples of singleton design patterns, and that is not sufficient to train a model. So, and industry people, they used mixed patterns, and well, they call it tactics, and most of the industry, they mainly use C++ or C programming language in their work, and most of the existing work, they have not exploited the semantic information of the program. So all these limitations that we are facing now in our project, based on this limitation and exploration of literature, we framed the three research queries, the three simplest research queries that we want to address. The first research query is that can we make a design pattern recognition tool that can address all the existing limitations? If yes, how effective that tool would be helpful for our industrial partner? And third, what are the understanding of design patterns in industry context? So basically, we are addressing three research queries, and we are doing three study to address one of the research queries here. In right now we are thinking to right now we are exploited one of the programming language model. So this is the graphical overview of how we can employ the programming language model to design pattern recognition. We try to the designer is responsible for adding the design patterns in the catalog and implementing design patterns in the program also. And the programming language models is useful to extract the information of the program. So basically, we are using this PLM, any one of the PLM that we explored to get the information of the program. And visualization is like we are visualizing the program to see the program to see the programs how they are close to each other in terms of PCA or TSNE. And we are also measuring the similarity, like the cosine similarity for our study. So in our first work, we collected some programs from open source repositories. We collected programs from GitHub, Stack Overflow, but only for C++. We also explored CPU adjusting PLMs to get to know which PLMs is suitable for our study. And we made a small train set, and we trained on the top of the PLM, and then we evaluated the performance. Apart from that, we also employed two developed modules from our industrial partners and applied our train model on that to get the predictions, and we will show the results. I will show the results of those predictions. And we also asked the original authors of those modules to get the feedback. We have not shared our results to them. We just asked what design patterns they have implemented on those codes. So all these things, I will show the results. So these kind of programs that we are using for our this study, it is a C++ based study. So we can see that the abstract factor design patterns, singleton design patterns for C++ and prototype design. This kind of programs we have used for our training purpose, for our visualization purpose, like initial study. Okay, so this is our pipeline for our first study. We feed the programs into the PLM, and we extracted the embedding. These are like embedding vectors from the code bases. On the top of that, after extracting the embeddings, we make a small train set, and we feed them into a neural network and get a trained model. And we have, after the training model, we also have the developed modules of our industrial partners. So we tested the developed modules from them on our prediction models. We used 16 program files of our industrial partners, and out of them are correctly predicted. This is the results. Here we can see that we used prototype and singleton design patterns. Yes, we can see green dots are singleton design patterns. Here red dots are prototype design patterns. These two developed modules are used for from our industrial partners. These are also making clusters. In the dendrogram visualization, you can also say that these developed modules are making clusters. Singleton are making clusters. So basically, what we are trying to say in this figure that these programming language models are capable to detect the design patterns in the implemented source code. So for our first study, and as we already use very small train set, so that is, we are not getting very good results, but we are getting some acceptable results. Almost 10 corrected results. Now our second study. This study is for Java based programs. This study is, there is one repository which is a baseline repository, PMART repository, which has some programs, but not very much, so that we cannot train any model. So we used this repository for visualization of a PLM that we explored in the previous study, and we used a distance measure, cosine distance measure, to measure the distance between the programs, and based on the distance measure, we evaluated the performance. So this is the graphical overview of our second work. Here we can see that the programs are fed into deep learning PLM models. We extracted again the embeddings from the decoder. Then we analyze based on the PCNA, PCA-TSNE and cosine measures. Then we predicted the design patterns and we evaluated the performance. So this is the graphical overview that we followed in this study. It is very similar to the first one, but here we are not. In the first study, we trained the model, but here we don't train the model. We are just visualizing it. So this is the results that we got as we used 5 different creation design patterns: abstract factory, builders, factory methods, prototype, and singletons. We get some different results. I mean, for instance, prototype, we can see that red dots are making clusters. However, in singleton, the dots are quite dispersed, and in factory methods, some portion are getting clusters here, but in some it is not. So we are getting some mixed results. Similarly, in abstract factory, they are making small clusters. So apart from TSNE, we also get PSCA visualization. Our PCA results is quite aligned with the TSNE visualization. Here we can also see that the clusters made by prototype design patterns in abstract factory design patterns, singleton is also dispersed. But this visualization is not sufficient to get the prediction results. So what we did, we evaluated using distance measure. We calculated the distance between 2 programs and then we evaluated predictions. I'm not diving into how we measure the distance, how we get the precision and recall. I'm just saying that we use this. So this is the results that we got from our cosine distances, and we compared with the 4 baseline methods, 5 baseline methods, and we found that our approach is outperformed in builders and factory methods design patterns. In singleton also. So apart from that, we also got almost 100% precision in abstract factory builders. So basically, these are like overfitted results. It's not overfitted. I mean, there could be some class imbalance problem, but we have added a lot of non-implemented design patterns in our program, so we cannot say that it is it could be a class imbalance problem. I'm not sure, but we try to avoid this class imbalance problem by adding a lot of non-implemented design patterns. And we also get amongst highest precision compared to the baseline methods. The conclusion from this study that using a small training set, we achieved very good results. We achieved 90% accuracy and 0.88% F score in our first study, and we used 60 modules from our industrial partner course, and out of 10 were correctly predicted by us. And we also found that these deep learning PLMs are very efficient to get the information about design patterns, and there could be strong models can be built on top of it using pre-training or something. So we are doing some further studies on that. So now our third study is about how the design patterns are understandable in automotive industry. So basically, what we did a small interview with 10 different participants across 3 different companies, and all the participants are either developers or architects of different levels. And okay, so these are the questions that we are trying to address in the interview study, and these questions are very generic. And for instance, the first such query is how architects and developers understand design patterns. What are the definitions they use? How they guide about design patterns to other people, to other developers or other architects. What are the level of design patterns implementation or freedom they follow? How they validate, how they recognize design patterns, and what are the good quality design patterns they think that they should have. It should have. So basically, what we did after performing the interviews, we did some thematic coding. We did both top-down and bottom-up thematic codings, and we extracted codes. Based on those codes, we created some themes also. So these are the interview questions that we ask, and this is the mapping table from our interview to our research question. We can see that all of the interview questions is mapped with the research question. So basically, this is the result that we got. We found five important themes based on our interview about guidance, about anatomy, about validation and checking, about usage of design patterns, about quality of design patterns. So basically, this is the result that we got. I will go through the summary of each of the research questions that we added in this, and then I will conclude the work. In the first research question, as I mentioned that how do software architects or developers in automotive industries understand or use design patterns? So basically, what we found in the software industries, they understand design patterns. They have different variety of design patterns. They have different understanding. And each of the understanding is related either with principles, design principles, frameworks, or standards of design patterns. And these standards and frameworks are like characteristics that they used to follow to apply design patterns. Second, how design patterns guidance they used to give, and we found that they usually recommend people to employ design patterns, but they ask the developers to follow the principles, and those principles can be design patterns. It is not mandatory. So they usually not prescribe design patterns, but they just give the guidance based on their experience. And what level of design patterns freedom they do exist? They have a lot of freedom, but all those freedoms are restricted based on several factors. For instance, standards. For instance, AUTOSAR standards. Some constraint from the supplier side. So, for instance, the supplier asked to apply this kind of design pattern, so they don't have choice to apply other design patterns. So, this kind of restrictions and freedom they do have. And how they detect or recognize design patterns or verify design patterns? We found that they usually do manual review, team review. They mentioned about some code checking tools, but we don't think so that those code checking tools covers the design patterns or not. And they also mentioned about some team working. I mean, they have a group of team that is dedicated to measure the design principles. And we are still not sure that those design principles cover the design patterns or not. Okay. So what are the good qualities of design patterns, they think? So basically, based on our interviews, we found that the consistency, code correctness, quality, and code responsibilities, abstractions and documentations are the factors that they think are the good quality of a design patterns. And they try to align all these factors to make a high quality software product. Basically, after this, in this study, we found that there is a diverse range of definitions from different architects. They have different definitions of design patterns. The role of an architect plays a very important thing to suggest or guide about design patterns, because a lot of architects, they are very experienced. They can guide or suggest about design patterns, but few of the architects, maybe they are not so experienced, so they feel they're reluctant to suggest something about design patterns. Need of alignment. There should be a better understanding and alignment between definitions of design patterns from academics to industries. And they have some restrictions of implementation. For instance, the participant mentioned that they faced a lot of restrictions. For instance, code limitations, library limitations, or from the client side also. Relationship with standards, the relationship between the, for instance, they mentioned about AUTOSAR a lot of times, and they also mentioned that they have to follow the standards, for instance, security standards or safety standards. So they have to follow those standards before or after thinking about design patterns implementation. benefits of design patterns. Design patterns, based on our investigation, we found that design patterns offer a better fit to improve the code readability, maintainability, and recognize it, and to better recognize the quality of the software. So these are the conclusions that we draw from our first study. Thank you. I think it was a bit fast this time.
Thank you. Perfect. Question or comments? Everybody wants to have coffee.
Yeah, definitely. But I can take one question.
Yeah.
If you go back a few slides where we're talking about what characterizes. Oops. Two. Ahead. One more, please. Come back. Now we lost. The what characterizes the design pattern to be of good quality? That page.
This one, the last one, IQ5.
Yes.
Okay, that I want to mention here.
Top. Yeah, good. Can you please explain the abstraction? What is meant by that?
They actually, they mainly talked about AutoSAR standards and abstractions layer. So what they're trying to say is that they have to follow some abstraction so that the people, because their codes used to go through several teams. So what they are trying to say that they have to mention the level of reading and abstraction so that the code and design should readable to or understandable to other people also.
Because to me, as I understand design pattern, I'm not definitely to my extent. I thought it was very, very specific.
Yeah, actually,
very narrowed, if you like. So that's why I react to this one.
Actually, the thing is, even the participants, they were also confused about design patterns because some of the participants, they mentioned that design principles is similar to design patterns. Design architecture is similar to design patterns. Even practice is similar to design patterns, but their definition is totally different in academia. So that is why they use words which is not exactly like design patterns, but according to them is a design pattern.
Okay.
So this, I think this study should be very important for understanding for industry, how they understand design patterns.
Yeah, but I think your first, sorry.
No.
Your first explanation that needs to be understood by different roles in the chain of development.
Yes.
Okay. Thanks.
Just curious in terms of the data set. I mean, you identified 5, 6 different design patterns, but I mean, there are many more. So how did you come up with the list? And
We're talking about this data set. We get this the PMAR data set.
I don't know. The stuff
Actually, we are talking about this data set.
Yeah, I mean, the graphs you showed at least 5 or 6 different clusters, for instance.
Yes, this one.
Yeah.
So actually, we are actually the PMAR repository contains a lot of design patterns.
Mm-hmm.
So basically, for our initial study, we only consider creational design patterns, so that we can get some findings on this, so that we can extend our experiment to other design patterns. So these are the examples of creational design patterns.
Okay. And I guess, I mean, at least for the creation design patterns, it's not that ambiguous. But for other design patterns that I guess you could have multiple patterns applied to the same snippet of code or same class. So is that dealt with in these data sets, or is it just an assumption that there is only one pattern that exists in each sample?
Actually, the thing is, the file that we used in the PMAR repository, it is mentioned that it is used only one design pattern. There could be many, but in the file it is mentioned that is why we are assuming that the file they are shading has only one implemented design pattern.
Okay.
So, yeah. So that is our assumption that each of the dots has only one design pattern, not more than one.
No, it's not the assumption. It's just how the data set is structured. So,
yeah.
So we know that it's only one thing.
Yeah.
But then when we were doing the study, the question also popped up: how do we find counter examples? Because they have to be somewhat similar from a similar data set, but they cannot be design patterns. And we want to evaluate all counter examples of non-design patterns, the same counter examples for all design patterns, or should we? another different design pattern could be a counterexample for another design pattern. So that is good thing. But in this data set, every file was labeled as or annotated as they have a specific pattern, or maybe two. I don't remember if that was the case,
yeah.
or if it doesn't have anything.